Welcome back to Summarize Science, where we break down the latest breakthroughs in technology. Today, we are looking at a fascinating paper about making AI smarter and faster through a framework called SpecGuard. Complex AI models are amazing at math and logic, but they're also incredibly expensive and slow to run in practical scenarios. One major issue with current methods is the reliance on external reward models, which often adds significant lag to the process. This high cost is a big hurdle for things like real-time digital assistants or complex engineering problem-solving tools. To speed things up, scientists usually use speculative decoding, where a small, lightweight AI makes a guess and a big AI verifies it. However, this process often gets stuck on tiny word-level errors that do not actually matter for the final logical answer. The researchers introduced SpecGuard to fix this specific bottleneck by focusing on entire reasoning steps. Instead of checking every single word, SpecGuard evaluates whether the whole step makes sense before moving on. Look at this architecture diagram, which shows how SpecGuard generates multiple candidate steps and filters them through an ensemble verifier. This internal verification is mathematically grounded to provide high confidence in every accepted reasoning step. This approach ensures the AI stays on track without needing slow and specialized external oversight models. They use two internal signals to verify these steps, grounding in the prompt and token-level confidence scores. By combining these signals, the system can decide whether to accept a draft or trigger a recomputation using the stronger target model. A key feature is the self-consistency selector, which helps the AI pick the most logical path from several different candidate guesses. It calculates a similarity score to ensure the chosen reasoning path is representative and not a random hallucination. In their experiments across various math and logic benchmarks, SpecGuard did not just match the speed of older methods, it surpassed them. They found it improved accuracy by about 3.6% while also reducing the time it takes to get an answer by roughly 11%. This chart shows that as the AI explores more candidates, its accuracy steadily improves without getting bogged down by noise. Unlike previous methods that relied on heavy external reward models, this system stays lightweight and scalable. The researchers even optimized the memory usage by only looking at the last few layers of the AI's internal attention mechanisms. This clever shortcut keeps the verification process fast enough for real-world deployment on standard hardware. By rejecting ungrounded or low-confidence steps early, the system prevents logical errors from spiraling out of control. Here, you can see an example of how the AI correctly breaks down a word problem into logical steps to find the right answer. It shows that more efficient AI does not have to mean less reliable AI when the right verification is in place. This research highlights that the key to better AI is not always bigger models, but smarter ways to verify the ones we already have. In the future, this kind of technology could make complex reasoning available on smaller devices like phones or tablets. It represents a major shift toward AI that checks its own work more naturally, much like a human proofreader would. To wrap up, SpecGuard is a major win for efficiency, proving that internal model signals are enough for high-quality verification. It means we could soon have AI assistants that are both faster and more accurate at helping us solve our hardest problems. Thanks for watching Summarize Science, and stay tuned for more deep dives into the research papers shaping our future. If you found this helpful, be sure to look up the full paper to see all the data behind these findings.